Hi, today I'm going to teach you how to solve bigger modular arithmetic question or the problem using an algorithm called square and multiply algorithm. So here is the question or the problem. Uh, is the problem that is 3 to the power 2021 mod 11. So we have to solve this problem. Let's say even though you are going to have a calculator in your exam, you cannot calculate this value, this 3 to the power 2021. It's that much of a big number. So let me show that number using this Python, Python interface, but you don't have to use these things, but I just want to show you that how to start that number is 3 to the power 2021. This is the number. I did this that we have more than 100 digits. So calculating this number, then you apply modulus operator is not that much possible. Due to the size of the number. So in that scenario, you have to use some kind of algorithm in order to solve this matter. So here I'm going to use, let me write the algorithm name, that is, let's see, different color. The algorithm name is and multiply. Algorithm. This algorithm name. Now I'm going to use this algorithm in order to solve this matter, solve this problem. Okay. So let me get another different color. So let's do this black. Okay. So the first thing you have to do is you have to get this 2021 into binary form. Okay. You have to turn this into binary form. So normally in exams, normally the calculators are provided, so you can just convert 2021 using calculator. But here I'm going to use the division algorithm to, or the continuous successive division method to get the binary form of this 2021. Let me write 2021 divided by 2 is 1 0 0, the remainder is 1. Okay, so let me do it again. 0 5 0 5, remainder is 0. So let me do it again. 0 2 5 2 1 is 1. Go to the again. 0 1 2 6. That is 0 0 0 6 3. I think this is, I think you know how to convert the decimal values into binary. If you do not know, just put a comment in the comment section, so then I can do another video how to do. I can explain more. Here, I think you can understand what I'm doing here, but if you do not have any idea about this, so I think it's better you can have some kind of, extra video in order to understand that. So it's 0 0 3 1, remainder is 1, divided times 2 0 0 1 x 5, remainder is 1, and divided again 2 0 0 0, it's 7, remainder is 1. Again 2, 0, 0, 0, 3, remainder is 1. Today is a rainy day. It's raining now outside. 2, 0, 0, 0, 1, remainder is 1. 2, 0, 0, 0, 0, remainder is 1. So this is the binary version of this 2021. So let me write that here. You say we are starting from this 0. Actually, it does not have any value, but I'm just writing it because that is standard. 1, 2, 3. Let me cross this out because otherwise I cannot find the correct value. 3, then 4, then 5, then 6, zero, 0, 1, 0, 1. 0, 0, 1, 0, 1. 0, 0, 1, 0, 1. This is the binary equivalent of 2021. So if you have a doubt, you can let's double check this from online calculator. So let me get another window, binary calculator. Calculator. Let's say 2021. Calculate with the value. So let me check. It's 0 and there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 ones and double 0, 1, 0. I think it's 1, 0, 1, right? 1, 0, 1. Yeah, 1, 0, 1. So our value is 5. Okay. So then there is an important thing I have to do, that is I have to write the binary position. So that is this is 2 to the power 0, this 2 to the power 1, this 2 to the power 2, this 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, 2 to the power 9, 2 to the power 10. So these are the binary positions. Okay. So then we have to write in below method. So that is the first one is 3 2 to the power 0, because here we have converted 2021, that is the exponent of 3. So now I'm writing these values using base 3 and 2 to the power 0, because this position is 2 to the power 0. Okay, so let me write here 2 to the power 0 means 1, and then 3 to the power 1 means 3, and here I'm writing the normal value. So then here I'm writing the modulus value, because our modulus is 11. So here the modulus value is also 3, because when I'm dividing 3 by 11, the remainder is 3. And here I have another position called answer. I'll explain that. So here our initial value is we have to write it here. Okay. So then next thing is 3 to the 2 to the power 1. Okay. Here I'm not going to write the exact, I mean the value. I mean the 3 to the power 2 means 2, 3 to the power 2 to the power 1 means 9. 9, but I'm not going to multiply this value or the square this value, because once we writing down, we can just square the previous value and get the current value. Square the previous value and get the current value. But if I'm going to square the actual value without applying modulus operator, so this value will be a higher values, large values. But here this value would be very low values. Low means lower than 11. Since the modulus is 11, so I think this is easy. So here, but in this case, it's nothing difference. Both values are same 9. But you can understand once I'm going further. So it's 9. But this is not goes to the answer area, since it's here, this is 0. This is 0. It's not going to the answer area. Okay. You have to just keep that in mind. So then 3 to the power 2 to the power 2. 3 to the power 2 equals, here I'm going to put it empty, and I'm going to square this value. It's 81. It's 81. Now I can show you the importance of squaring the mod value instead of the actual value. If I'm going to but not here, the next step I'll show that here the 81 is congruent to this to when I'm dividing 81 by 11, it's 77, and remainder is 4. It's 4, and our to the power 2 field is 1. So then this value should goes to the answer. So then we have to multiply the previous value by the current value. Okay, now it's 12, but the mod value will be 1, because when I divide 12 by 11, the remainder is 1. Okay. Now I'm going to tell you why I'm not squaring the actual value, and instead of that I'm squaring the mod value. So the reason is, so let's try this. 3 to the power 2 to the power 3. So if I'm going to write this value 81 here and going to square it, the 81 square means a larger number. So but here the mod value is 4, the square is 16. So it's easy. It's 16, and the mod value of that 16 also will be 5, because when I divide 16 by 5, the remainder is 5. Let me check whether 2 to the power 3 is close to the answer. No, because since it's the value 0 here, value 0, now it is not going to the answer. Okay. Oh, sorry. Okay. So I think it's better if I send it dash. Not going to the answer. Okay. So then it's very difficult to solve this. Okay. Now let me go to this question. 3 to the power 2 to the power 4. Here it's there should be 5 square. 5 square means 25. But the mod value should be it's 3, because when I divide 25 by 11, the remainder is 3. Let me check whether this goes to the answer. 3 to the power 4. It is also not going to the answer, because it's also 0. So I'm just putting a dash here. Then let me type this next step. 3 to the power 2 to the power 5. It's 3 square, that means 9, so it's not going to be changed. But here 2 to the power 5, it's 1, so then that means it goes to the answer. So then you have to multiply the previous value is 1 by 9, and here it's 9. Okay. So then let's go to the 3 to the power 6. 3 to the power 6. So we have to square this value. It's 81, and it's going to, when I divide 81 by 11, the remainder would be 4. So let me check with the 2 to the power 6 as digit 1. Yeah, so then it should be going into the answer. So 9 into 4 is 36, congruent to 3. I think I assume that you know this congruent or the triple dash mark. If you do not know that, just put a comment, so then I can post a video with all the basics of modular arithmetic. I can this video has been posted with the assumption that you have the basic idea for the basic concepts of about modular arithmetic. If you do not have any idea about modular arithmetic and you want to solve these type of equations, so then you just put a comment. I can post a video with all the basics of modular arithmetic. Okay, because I'm not going to explain all the things here, because otherwise this is going to be a complicated video, so that's why I'm just neglecting these theories here. So let's do this. So once you put a comment, only I can do a video. Okay, let me go to the next step. That is 3 to the power 2 to the power 7. So then I have to multiply square this. That is 16. It's going to 1. Once I divide 16 by 11, the remainder is 5. So let me check whether 2 to the power 7 is in. Yeah, it's 1. So then I have to take this as the answer. So 2 to the power 5. Because I'm getting the previous value and multiply by the current value. So now it's 15. It's congruent to 4 since I divide 15 by 11, the remainder is 4. Okay. Let me next step. 8 equals 9 square 5 is 25, and it's congruent to 3 because when I divide 25 by 11 it's 22, that's remainder is 3. So let me check whether 2 to the power 8 is yeah, it's 1, so then it should be go to the answer section, and here the previous value is 4, and I'm multiplying by 3, and it's 12, and it's congruent to 1, because when I divide 12 by 11, it's the remainder is 1, and then the next step is it's to the power 9. Here it's 9, once I square 3, it's 9, and let me check whether it's to the power 9 is, it has 1, so then it should be going into the answer section. 1 into 9 is 9, and then 3 to the power 10, I think that is our final step, so it also should be going into the answer, equals here it's 81, and it's congruent to 4, because once I divide 81 by 11 it's 77, the remainder is 4, and it should be going to the answer. 9 into 4 is 36. So the modular, when I activate the mod operator here, it should be 3. So this should be the answer. This should be the answer. But let me give you that answer checked using Python interface here. Okay. Our value is 3 to the power 2021 modulus 11. Yeah, the answer is 3. So that means our answer is correct. I think you got some kind of idea about this square and multiply algorithm. So if you have any questions regarding my teaching and my theories that I have taught here, so just put a comment. I can post another video clarifying those issues. I think you have get some kind of idea about how to solve this type of matter or the problem using this square and multiply algorithm. So thank you so much for your time. So let's meet in the next video.